In this lesson, we'll go over factoring quadratic expressions, Part 1. Our objectives are to learn how to factor quadratic expressions when the leading coefficient is 1, learn how to factor using the difference of two perfect squares, again when the leading coefficient is 1, and we'll understand how to check your answer. Factoring essentially means to undo with multiplication. We always look for a greatest common factor first. So some practice with that. With greatest common factor, or GCF, factor completely. Part A, 20b cubed plus 16b squared. When you're looking for a greatest common factor, you're looking at both the greatest common factor between the number and also the variable. In this case, between 20 and 16, our greatest factor, or the biggest number that goes into both of them, is 4. And between b cubed and b squared is the common factor in both. And to see that, you can write this as b times b times b, b times b. There's 2 here, and there's also 2 there as well. So our greatest common factor is 4b squared. So essentially what we're doing is we're pulling that out and determining what's left. So we have 4b squared. There's 2 ways to go about this. If you take a 4 out of 20, you have 5 left. And if we take b squared out of b cubed, we just have b left. If we take 4 out of 16, we're left with 4. And if we have b squared on the outside here, there's none left on the inside. So our answer in factored form is 4b squared times 5b plus 4. Another way you may think of this is dividing each of these by 4b squared to determine what goes on the inside. Now the way to check your answer is to distribute or multiply it back out. Since factoring is undoing with multiplication, we multiply to see if we get the same as what we started with. So we'll take 4b squared times 5b. 4 times 5 is 20. b squared times b, remember rules of exponents, this becomes b cubed. 4b squared times 4 is 16b squared, and we got what we started with, so our answer is correct. Moving on to part B, 4x squared plus 8x plus 20. Our greatest common factor between our numbers, we have 4, 8, and 20 is 4. And between our variables, we have x squared x, and then there's no x's on the end. That means we can't take any out because it's not in common. Okay, so in this case, it's like we're going to divide each of these terms by 4. So 4 stays on the outside. We have x squared plus 2x plus 5. And don't forget about the 4, because as you'll see when we check our work, we have to get back to the original. So in order to check, we multiply or distribute the 4. So 4 times x squared is 4x squared, 4 times 2x is 8x, and 4 times 5 is 20. Notice if you left the 4 out, you would just have x squared plus 2x plus 5, which is not the same as the original. Quadratic expressions. This is really what our focus is going to be for factoring and for solving in the following section. Quadratic expressions come in the form of ax squared plus bx plus c. It's quadratic because the highest power of our variable is squared. Remember we talked about linear equations where we were just dealing with x. Okay, this is what makes it quadratic, is the x squared. When we talk about quadratic expressions, a is always the coefficient or the number in front of x squared, b is always the coefficient or the number in front of x, and c is always the constant. It has no x's with it. Recall from the previous section, before we start factoring, this is already in factored form, if we distribute x times x is x squared, negative 3, x times 4 is 4x, negative 3 times x is negative 3x, and negative 3 times 4 is negative 12. So if we were to simplify this, we have x squared plus x minus 12. And notice what's happening here. The negative 3 and the positive 4 add together to give 1x, or to give 1, which is the coefficient of x. And negative 3 and positive 4 also multiply to give negative 12. So keep this in mind as we begin factoring. Example 1, factoring when the leading coefficient, a, is 1. So the instructions are to factor completely, and we'll go through a couple different ways to do this. First, using what we just talked about, if we were going to factor this example, let's say we were just given the x squared plus x minus 12. Let me rewrite it. Since the leading coefficient is 1, you can think of two numbers that multiply to give negative 12, but add to give positive 1. In this case, it would be 4 and negative 3. So that is how we would build our two factors. So we can apply the same here. We can look for two numbers that multiply to give us 8 and add to give us negative 6. Now, since we're multiplying to a positive, our options are two positive numbers or two negative numbers. That's the only way to multiply and get a positive when we're talking about two numbers. Since our two numbers are adding to a negative, it narrows it down that we're looking for two negative numbers. So you can start to write these out. Negative 1, negative 8, that adds to negative 9, so it's a no. Negative 2, negative 4, that adds to negative 6, so that's what we'll use. So we would have x minus 2 and x minus 4. Another way to do this problem is what my former students have called the x method, which will work when we go to factor more complicated quadratic expressions. So we start with the x. What we're trying to multiply to goes at the top. What we're trying to add to goes in the bottom. Okay. And then the two numbers of your choosing go on the sides. So we already know it's negative 2, negative 4. Okay. With this method, you would divide by whatever number's in front of x squared, which I promise will come in handy later. And then to build our factors, the number in the denominator becomes the coefficient of x minus 2, and then we have x minus 4 in front of x squared minus 4. Okay. And again, we can always check our work with these. So if we take negative x minus 2, x minus 4, you would distribute or FOIL to determine if we get the same as what we started with. X times x times negative 4, negative 2x, positive 8, x squared minus 6x plus 8. So our answer is x minus 2 and x minus 4. In the next example, we have x squared plus 14x plus 49. Depending on how you do this, you're looking for two numbers that multiply to give 49 and add together to give 14x. In this case, 49 is 1 times 49 or 7 times 7. So this would be x plus 7 times x plus 7. Notice x plus 7 times itself can be written as x plus 7 squared. So the expression that we started with, you might see as referring to a perfect square trinomial, is because when it factors to a perfect square. Or it is a perfect square, and the factorization is x plus 7 squared. Okay, notice how the square root of 49 is 7, and since it's positive, it'll add to 14x. And again, you could check your answer by multiplying it out. Last example, factoring the difference of two perfect squares. So typically when we have two perfect squares, the giveaway is that we're dealing with two terms. One of them is our variable squared and the other is the constant. Okay, our middle term or our b term is missing, but you could write it as 0y if you wanted to, which is a way to solve this or to factor it if you want to do it the way that the previous two examples have been done. Okay. But the way that these problems work, actually we'll take it from here. If we're looking for two numbers to multiply to negative 49 but add to 0, okay, that would have to be 7 and negative 7. 7 times negative 7 is negative 49, and 7 plus negative 7 is 0. So this would factor into y minus 7, y plus 7. So when we're dealing with the difference of two perfect squares, we have a perfect square minus, for difference, another perfect square, and it factors into the square root of the first term minus the square root of the second, and same thing, square root of the first term plus the square root of the second term. So in the first part, y was squared, the square root of y squared is just y. 49, the square root of 49 is 7, so we have y minus 7 and y plus 7. Next, in part B, I want to emphasize that the order is important here. Our first term is 6. Our second term is v. Okay, both of them are squared, and so we can use the difference of two perfect squares. So this becomes 6 minus v, 6 plus v. And the order here is very important. Remember to check your answer. You multiply it back out. 6 times 6 is 36. 6 times v is 6v. Negative v times 6 is negative 6v, and negative v times v is negative v squared. You have to get back to the original. If you did something like v minus 6, v plus 6, you would not get the same result, and I'll let you check that on your own. Factoring is really important, not only for this class, but for your future classes. So if you're struggling or if you have any questions, I would be happy to help you.